All right, so today we're going to be talking about measuring and naming angles as we start into our angles and triangles unit. So the first thing we need to know is that two rays that share the same vertex form an angle. So for instance, this is a ray right here. This is ray BL, and then this is ray CB, which means that they share the same vertex, which is B. So the point where the rays intersect is called the vertex of the angle. And two rays are called the legs of an angle. And how do we name an angle? Well, we name it using three letters. One from each ray with the vertex in the middle. So for instance here, angle 1, I could also call it LBC. So I could call that angle LBC, and you'll see both. You'll see it named with the letters, then you also might see it named with a number there. Angle 2 then is going to start with C, and it is going to be CBD. So angle 2 could also be called angle CBD. Our next one there is going to be angle DBA. And then our last one there is going to be angle ABM. So once again, we've seen two different ways to name the angles. We can name them with the letters, and then you can see how they've numbered them as well. So if it's talking about angle 1, well, it's talking about angle LBC. Those are the same thing. Now there are four types of angles. We have an acute angle, which an acute angle is less than 90 degrees. An obtuse angle is greater than 90 degrees. A right angle is exactly 90 degrees, and a straight angle is exactly 180 degrees. So an acute angle, so I'm going to start with the right angle actually. A right angle looks like the letter L. And we put a little square on there to show that it is 90 degrees. Now an obtuse angle is bigger than that. So a straight angle is flat, and this is 180 degrees. So my obtuse angle is going to be in between these two. So it's not quite straight, but it's bigger than 90. So for instance, that could be like 130 degrees, we'll say. My acute angle then is going to be smaller than my right angle. So say that's like a 60-degree angle, so something less than 90. Now these can also open the opposite ways. So I want to show what those look like. So if you see these and they're backwards, they still work. Obviously 180 is just 180, there's a straight line. But if you see these and they're backwards, they still work the same way. When I'm measuring with a protractor, as with this one shown here, this one for number 1 says I'm going to use my protractor and estimate this. So I put the vertex right in the center. This bottom line has to line up with the bottom edge. It's got to be at 0. Now if my angle had opened up this way, I would line it up this way, and I would read my numbers differently, and I'll show you that on the real protractor here in a second. And then measuring how far apart these are, that's what the angle is. So when I come through here, this is 0, 5, 10, 15, 20, 25. So that angle shown with that protractor is about a 25-degree angle. Now our next one here, I'm showing you here with a real protractor. So this is my vertex right there. It's lined up in my dot. This line, there's a black line on your protractor, and that is what you line that up with. And then sometimes you need to kind of extend this out here if it's not quite long enough so that you can see like where this would be pointing to. Since I'm starting on this side, I'm going to use the numbers that count up from 0. So that means this one's bigger than 90 degrees, and it's about 105 degrees. You may say 104, depending on when you extend your line where it ends up with. If my line had gone this way, then I would have counted from here as well. So once again, line it up. There's my vertex. I start here. I'm going to go 0, 10, 20, 30, 40, 50, 60, 70, 80. And this guy looks like he's kind of in here in between. So I would say that he's about 83 or 82 degrees. Somewhere around in there. I'm sorry, I turned my paper on you. So it'd be about 83 degrees on that one. This one right here goes past the 90. And it's kind of hard to see, so this is one of those ones where you might want to take your paper and turn this and extend it using your straight edge, because that line is just not long enough. And that would make it hard for us to get a read on. So I'm going to go ahead and put it there. And I'm starting from 0, so I'm counting these bottom numbers here. And it looks like it's about 159 degrees there. Down at the bottom here, I'm going to show you how to draw some opening that way. I'm going to also show you how to draw some going the other way. So the first thing I want to do, I notice that this is obtuse, and I need a bottom straight. I'm going to need to be able to get to that 140 on here, and you can see I had to white some things out. So I need to be able to get to that 140. So I'm going to need my vertex to be at least over here. I didn't quite make that far enough over the first time, so thank goodness for whiteout tape. So when I put that down here like this, I'm going to line that up. I'm going to find, counting from 0 over to 140. Then I'm going to turn my paper. Sorry if I'm giving you a motion sickness here. I'm going to line that up and connect it. So I just took this and I lined that up and I connected it. And that means that my angle right here is a 140 degree angle. For my 35 degree one, I'm going to open it up the other way and show you what that looks like. So I'm going to draw my line. I'm going to put my vertex over here. When I put this down, I'm going to start counting from 0 over here. So you notice it looks like it starts at 170, which would be 180 on a straight angle. So I'm going to use the top numbers now. So 35 for me is going to be right there. I'm not going to draw my line that long, but I'm going to use that to match it up and line it up. And then I can make that line however long I want, but that is a 35 degree angle, and it's an acute angle. It's just that it opens the other direction. I want you to see how to use the protractor going that way as well. I'm going to do 80 degrees and open it up to the other side as well. And I can do these either way. You know, the angles can open up either direction. So this one, if I go to 80, I'm going to put my mark. And once again, I don't have to draw it that long. I just needed to make my mark out there so I could line my points up, because that was where my protractor met at. And so that is an 80 degree angle. On the back, we're going to talk about some angle pairs. So adjacent angles are angles that are next to each other. So they have a common leg and a common vertex. So you might have noticed on the other side that when I was drawing what these angles were, so like if this was angle 1, and I said, oh, angle 1 is also called LBC. And then when I went to do the next one, I had to go right along that same line. So these are what we call adjacent angles. Adjacent means to be next to. So C to B to D, these are adjacent or next to each other. Now this same angle, CBD, is also adjacent to angle DBA. And then angle DBA is also adjacent to angle ABM. Now, the angles don't have to be the same size. So you're looking at this and you're like, well, there's more spaces there. So if I go to this angle right here, I could also have, let me grab a different color here, I could also have added in, next to this I could start here again, but instead of going right up here, I could have gone up this way. So that means that angle LBC is also adjacent to angle CBA. Another one that I could have done as well to LBC is also angle CBM. So you can see they can be adjacent to each other because they only have to share a side, but they can also be different sizes. One can be a lot bigger than another, and they can be adjacent angles. So our last one here, we had that angle CBD, if you remember, and adjacent to that is also DBM. So those angles are all next to each other. Now, angles that are next to each other and add up to a certain amount have a special name as well. So two angles that are adjacent to each other and if I add them up, they have a sum of 180 degrees. Those are called supplementary. So if I looked at these right here, if I were to use my protractors, angle LJC and angle CJG, if I added up those angles, they make 180 degrees because they make that straight line down there. So if LJC is 95 degrees, because it's a little bigger than 90, I could do 180 minus 95, and I would get that it was 85 degrees. Now, if the two angles come together and equal 90 degrees, then I have a complementary angle. So PMZ and ZMS equal 90 degrees. So if PMZ is 44, I just have to subtract, and I would get 46 degrees for the other one. Other types of angles that you might see are vertical angles, and vertical angles are directly across from each other, and I always think of it like they're pointing at each other. And vertical angles are angles that are equal to each other, and they're formed by the intersection of two lines, and they are across from each other. Those are kind of interchangeable. They're going to be equal to each other. So like if this one's 60 degrees, this one's 60 degrees. Now this is a straight line, which means that this must be 120 degrees. These are also vertical, which means that this is also 120 degrees. You're going to be practicing with these. Let us know if you have any questions. Use these notes when you're practicing.